Welcome to my channel, new content class. Today, I would like to discuss very important segment of chemistry, 12th class chemistry, first chapter, solid state. Earlier, I made three videos, part 1, part 2, part 3, in which I have discussed about the introduction of the solid state, crystalline state, difference between the crystalline and amorphous state, and classification of crystalline substances, as well as I have explained the unit cell, different kind of unit cell like face center, body center, hand center, etc. As well as I have discussed closed packing, one dimension closed packing, two dimension closed packing, three dimension closed packing, which form hexagonal closed packing as square closed packing. Also, I have discussed square closed packing and hexagonal closed packing. Also, I told you that in earlier videos about the voids. There are two types of voids, tetrahedral voids and octahedral voids. Simply, we can say that total number of voids are present in any unit cell are 3n, while tetrahedral voids are 2n and octahedral voids are 1n. Now I would like to discuss about the packing efficiency. Packing efficiency. Everyone know that what is the meaning of packing efficiency? The fraction of the total space. The fraction of the total space of occupied is known as a packing efficiency. Means that whenever we take any kind of box, okay, in which the particular atoms are arranged in closely packed, like in a square packed closed packing or hexagonal closed packing. So total number of space covered by a atom or remaining space is known as a 100%. That is known as 100%, and whole space is occupied by the atom is called a packing efficiency. Okay, packing efficiency is very important part of this one discussion. So the packing efficiency. Okay. So packing efficiency we have discussed for three things. Number one, simple cubic cell. Simple cubic cell arrangement or simple unit cell. For the simple unit cell, for simple unit cell, the packing efficiency is calculated by one important formula. That important formula is percentage of occupied volume, percentage of occupied volume, okay, of simple unit cell equal volume, VOLUME, volume of a sphere, sphere, as well as it divided by volume of cube, volume of cube. So it will be the formula 4 upon 3 pi RQ upon 8 RQ multiplied by 100, because we are finding out percentage. So the percentage will be 52.4%. This is the packing efficiency. It means that remaining part is find out whenever this one 52.4 subtracted from 100. Okay, this is the first type of packing efficiency. Now second one type of packing efficiency for body centered cubic cell. Body centered cubic cell. So body centered cubic 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 unit cell. Okay, this is very important. Now for this also we know that how we find out. We have to concentrate on I will make another video for the packing derivation of packing efficiency for a 12th class point of view, CBSE 12th CBSE board point of view. This much is sufficient. Okay, so percentage volume occupied is simply volume of spheres. Why spheres? Because in body center there are two spheres are present, while in simple cubic cell only volume of cube. Volume of cube is dependent on type of the unit cell. Okay, so volume of cube is like this. Eight upon 3 pi r cube. 8 upon 3 pi r cube upon 64 by 3 root 3 and 4 r cube multiplied by 100 become 68%. The packing efficiency for body centered cubic unit cell is 68%. For the face center or CCP or HCP will be 74%. No need to find out because earlier I have discussed two type of the unit cell. For packing efficiency. Now, very important topic for that finding out the density of any unit cell is. Now we are moving on one important question which is asked by examiner in different examinations, like density of unit cell. So density of unit cell equal, first of all, Z is number of atoms are present in a respective unit cell, and molar mass capital M upon AQ, volume of one unit, and Na, Avogadro number. Okay, if in one question if somebody asks that what is the density of unit cell for which kind of a unit cell, let me see. There is a one numerical I want to find out that kind of a. So for the face centered unit cell means Z equal 4, which having A equal 408.6 picometer, which will be 408.6 into 10 to the power minus 10 centimeter. Picometer should convert into centimeter. because we are finding out unit set. Centimeter is a big unit, we can find out, and capital M means molar mass of a respective substance is given 107.4. Okay, and also it is also given by the Avogadro number. Everyone know that. So whenever we put these values to density, it is density equal Z is 4, M is 107.84 upon AQ. AQ means 408.6 whole cube and 10 to the power minus 10 whole cube and 6.023 into 10 to the power 23. So whenever we calculate, we find out 10.5 gram per cubic centimeter. This is the density. Okay, density of 1 unit cell. This is the one example. In another video, I will give you different kind of example. So now I am summarizing all the points or topics for the theoretical point of view. Okay, numerical point of view, I will make another video. Now we have to move ahead. We know that whenever we prepare some crystal in laboratory or we heat any kind of substances, we know that some difficulties, some atoms are misplaced from their point. So simply we can say that in any crystalline substance, if all atoms are arranged in regular manner, then these kind of substances are called perfect crystal. Perfect crystal. CRYSTAL. Perfect crystals. Perfect crystals are very important. So first of all, we have to understand what are the perfect crystal or ideal crystal. Ideal crystal or ideal crystal. Ideal crystal. Okay. So ideal crystal means if we make this kind of crystal, in this crystal we are observing all atoms, ions are present in proper or regular manner. We can show positive, negative, positive, negative. Okay, so this is the perfect crystal. Okay. Now another point. That another point is imperfection. Imperfection means whenever we heat, imperfection means some defect, some defects. Okay, defect means any atoms or ion misplaced from their particular area or a particular point. That is known as defects. These defects are also known as a point defect. These are known as a point defects. Okay, so these point defects are 3 types. Number 1, stoichiometric defect. Metric defect. Okay. Second one, non-stoichiometric defect. Defect. Okay. And third one is impurity defect. Defect. Okay. impurity defect. So now we will discuss all these defects in detail. Now, second one thing, we have to take a snap. We have to discuss from beginning. Number one, stoichiometric defect. In stoichiometric defect, first point is vacancy defect. Vacancy defect. Okay. The vacancy defects means whenever any atom is misplaced from their particular portion. Like it was the perfect crystal and some crystals are disappear. So that is known as a vacancy defect. This vacancy defect is also created by displacement of cation or anions. Now, second one type is interstitial defect. Interstitial defect. Interstitial defect means these are the proper arrangement of atoms or ions. Okay, some atoms or ion misplace from there. Okay, like they misplace and reach over here. This kind of defect is called interstitial defect. Now we have to discuss about the ionic defects or ionic solids in point of on the behalf of the ionic defect. So very first is very important Schottky defect. SCHO Schottky, double T, Schottky defect. We are showing that we are seeing that there is a Schottky defect. This defect is on the behalf of the name of the scientist. It was the Schottky who was discussed that, who was also research on the sodium chloride crystal. He found that whenever we heat the sodium chloride, some cations or anions shot from their particular position. So that kind of a defect is called a Schottky defect. Schottky defect only is created due to three reasons. Number one, if large coordination number is found. Okay, and B, if cations and anions are in same size, then Schottky defect is found. Another thing, by heating, that is why these kind of defects are called thermal defect. Okay, so due to the Schottky defect, the density of unit cell is lower. These are the consequences of the Schottky defect. For simply, sodium chloride is the best example of Schottky defect. We can show this kind of Schottky defect by the help of this. Whenever the one positive, negative, positive, negative, positive, negative, positive, negative, positive, positive, negative, positive, negative, negative, positive, negative, positive. If one anion and one cation is missing from their point or their position, so that kind of defect is a Schottky defect. This is good, better example of the Schottky defect. Now, another defect is fractal defect. By the name of fractal means frankna, or we can simply say that anion or cation displace from their point and reach in the interstitial position. Okay, so that kind of defect is called fractal defect. Fractal defect is found in fractal defect is found in AGCL fractal, FRANT fractal defect. Okay, fractal defect. So in fractal defect, why fractal defect is found? It is found due to low coordination number, low coordination number. Okay, and second one, in anions are larger than cation. Okay, when anions are larger than cation and lower the coordination number, then fractal defect is simply obviously that whenever cation are smaller in size, they reach in interstitial position. That is why fractal defect is occurs. So in this kind of defect, no density is less, or density does not effect on the fractal defect. So for example, ACBR. Okay, this is the example. Simply by the diagrammatically, I want to show you that these are the anions or cations. These one anion, cation, anion, cation, anion, anion, cation, anion, cation, cation, anion, cation, anion. Okay. When one cation is reached over here, this is the fractal defect. Understand? So vacancy is created near the anion or cation. Vacancy is created. So this is called a fractal defect. Now another kind of the fractal, another kind of defects are number one, number second, non-stoichiometric defect. These non-stoichiometric defect, non-stoichiometric defect. Okay, non-stoichiometric defect. These non-stoichiometric defects are two types. Number one, metal axis defect. Metal axis defect. Okay, metal axis defect. Simply we can say that in metal axis defect, the very important example is by anion vacancy. By anion vacancy. Okay. This kind of vacancy is created whenever we take one example, NaCl. We heat this NaCl. Okay. So Cl minus ion displace from their particular point and make a one hole. That kind of hole is covered by electrode. Due to covered by electrode, the yellow color is appeared due to the trapping of electromagnetic waves in the electron. So simply positive, negative, 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 positive. Whenever negative ion, okay, is displaced anywhere and form and electron is occupied, so F center is formed. What is that? F center. is formed. F centered is formed with so F centered means color is formed. Color is given by the particular crystal substance. For example, NaCl. But whenever we talk about the zinc oxide, that zinc oxide formed by the presence of extra cation at the interstitial site. By the presence extra cation at interstitial position. For example, ZnO when heated convert into Zn plus and O minus 1 by 2 O2 or 2 electrons we got. So this kind of defect is called by presence of extra cation at the interstitial site. This is found in a zinc oxide. Now, other kind of defect are metal deficiency defect. Metal deficiency means coming. Deficiency defect. Okay, so this is the metal deficiency defect. First one is bication. In briefly we have to discuss bication vacancy by CATION cation vacancy. Cation vacancies. So in cation bication vacancy, this kind of defect is present in some crystal in which cations are missing from their lattice site. When cations are missing from lattice site, the metal cation deficiency is formed. Okay, this is simply formed in iron oxide, FeO. Okay, in iron oxide. So in iron oxide, in form of like 0.93, and oxygen is found as 2 Fe found at 0.95. Okay, but this defect is not found in Fe. Okay, so it was the metal deficiency defect due to cation vacancy. So cations are not found in a crystal lattice. Now last one is impurity defect. First of all, we have to rough this one thing. Okay. Impurity defect. So impurity defect is found whenever NaCl is doped in SR. Okay, so Na plus ion replaced by SR ion. This kind of defect is called a impurity defect. Simply like cation, anion, cation, anion, anion, cation, anion. This is the perfect crystal of NaCl. So positive, negative, positive, negative. Positive is represent for Na plus sign, negative is represent for a Cl minus sign. Understand? Cl minus sign. So positive, negative, positive, negative, positive. If we replace this one by the Sr plus 1, this kind of defect is called a impurity defect. So it was a explanation of best explanation of impurity defect. Children, I will provide you the chapter by notes of each and every chapter. I will make a video of these kind of notes also. So now we have to move on another topic, that is known as the nature of bonding in metals. Metals or conductors. Okay, metals having positive charge, electron, positive charge, electron, positive charge. This kind of arrangement is formed. This kind of arrangement is also known as kernels are spread in a sea of electrons. These electrons are free electrons. Okay, these are free electrons, and particular portion of the cations are called kernels. Due to movement of free electrons, electrical conductivity is possible in any metal. Now, this kind of electrical conductivity is explained on the behalf of the molecular orbital theory. According to molecular orbital theory or bond theory, is found that there are two types of bands are present. These kind of bands, these are not bond, these are bands. So I am going to represent this one band like this is the energy. Everyone know that there is a lesser energy, और ये high energy. एनर्जी की बात हो रही है. Okay. If we take one example of metal like copper, so this one is a conducting band. CAND. Okay, and this one is a valence C-bond band, valence band. Okay, in which outermost we can say that the valence electrons are present. So this is a lesser gap. This is called a forbidden region. Forbidden band या forbidden zone. This is for conductor, because we know that there are three kind of metals: conductors, insulator and semiconductor. So semiconductors like have this kind of band, okay, but semiconductor and insulator have this kind of gap. It means that insulator having very large gap between valency band and conduction band. These are the conduction band, these are the valency band. But important topic is that whenever we increase the temperature, okay, in Kelvin, the conductivity of metal decrease. While whenever we heat up the semiconductor, conductivity will increase. These are the insulators. So it was the band theory of the conductors, insulator and semiconductor. Now remaining topics are, I want to tell you, magnetic properties or magnetic behavior of conductors. So these magnetic behavior of conductors are, okay. Before going to magnetic behavior, I would like to discuss about p-type, p-type, p-type semiconductors. Second one, n-type semiconductors. Okay, first of all, I have to write down the all names. Okay, so I would like to another topics we have to discuss. P-type semiconductor. Whenever we doping means whenever we dope 14 group element, 14 group element with a 13 group element, 13. Okay, with a 14 group element, 14 group element with a 13 group element like gallium, okay, and boron, etc. So p-type semiconductors are found, okay, whenever 13 group element, 14 group element, 14 group elements are doped with 15 group element. So we found n-type semiconductor. These n-type or p-type semiconductors form different kind of utilizable property like n-p, n-type semiconductor, p-type semiconductors which are used in transistors, etc. So another topic, single unpaired electron, unpaired electron. Unpaired electrons, if are found in any kind of element classification, these kind of substances attracted in magnetic field. So these substances are called paramagnetic. If electrons are present in a paired condition, this is a paired. This is a paired. Okay, so paired condition, that is diamagnetic, which is not attracted by any kind of magnetic field. Ferromagnetic substance. These ferromagnetic substances are very important according to on the point of ferromagnetic. So a few solids like iron, O1, okay, and nickel, these are attracted very strongly in magnetic field. Okay, these are known as ferromagnetic solids. These are the ferromagnetic solids. So in ferromagnetic solids, electrons are attracted in magnetic field, which are present in a clockwise manner of spin condition. Now next one type, antiferromagnetic. In antiferromagnetic, the magnetic moment of each domain means area of electron present. Area of electrons are present. These kind of area are called in which electrons are present are called a domain. So these are the antiferro magnetic solids. Antiferro. Last one type are ferrimagnetic solids. Ferri magnetic solids. Okay, ferrimagnetic solids. In ferrimagnetic solids, the domains are such kind of like 2 electrons are present in a clockwise, while 1 electron are present in a anti-clockwise. 2 electrons are present in clockwise, while 1 electron. These kind of substances lose their ferromagnetic whenever we heat it. So, children, I have summarized whole of the chapter. This is very important regarding the NEET examination and ITG examination as well as for CBSE examination. I have given you whole theoretical portion of the solid state. This is sufficient for CBSE board, and in next time whenever I make a new video, I will make a video for solution of NCERT questions as well as for another books solutions, because whenever do the more practice of the question answer, in that way you will be a more expert and you will write down in a short time. And children, I want to tell you that whenever you will complete this chapter, you have to start solving the question answer, which is very important. And like and subscribe my video, also my channel new quantum classes, which is providing you very fantastic syllabus notes, I think valuable topics on valuable topics. Thank you so much. Have a good day.